Assalamu alaikum. Welcome again, my students, to continue kinetics and to continue in specific, Ustaz, factors affecting rate of reactions. We took two factors, and the third one we started to talk about it in the previous video. أخذنا concentration وأخذنا surface area, صح? We talked about temperature, and I told you, يا أصدقائي, إنه we have to include collision theory principles in the explanation. وحكينا أستاذ, if we have a chemical reaction in the exam, a chemical reaction, let's say, operates at 300 Kelvin or 400 Kelvin, and temperature increases to 500, 600, whatever, rate of reaction increases for sure, أستاذ, من دون أي discussion. Rate of reaction is faster, our reactions operates faster at higher temperatures. دائما أستاذ. But if they ask us to explain, please to include the increase or the increase in kinetic energy of reactant particles. Include this in your answer. شو قصدك أستاذ? What do I mean is, at higher temperature, kinetic energy of reactant particles increases. أنا بحب هدول kinetic energy of reactant particles increases, which make them move faster. And as we remember before, Ustaz, reactant particles start to collide more frequently, or number of collisions increases, which increase the collisions that able or overcome activation energy, which makes the reaction faster. تمام. This is the theory part. في عنا diagram to represent the effect of increasing the temperature of on the chemical reaction or on the rate of reaction. لا خليك. Which is Maxwell-Boltzmann distribution, and I need it full screen. Maxwell-Boltzmann distribution first used to describe or to study the kinetic theory of kinetic molecular theory. The effect of temperature on the kinetic energy of particles. As temperature increases, energy or kinetic energy increases. But in this case, be careful, this is a common question in AP. Sometimes they're going to ask us a distribution. We already have a distribution, okay? And in the exam, let's say they ask us temperature increases or decreases. Draw another distribution to describe the effect of increasing or decreasing temperature. شو قصدك أستاذ؟ Maxwell-Boltzmann distribution describe the relationship between molecules, number of molecules, and the kinetic energy. وهون في two graphs أستاذ. we should draw two graphs. لا بس واحد. Already you have one of them, which is, let's say, the blue one, okay? At lower temperature. We have a chemical reaction operates at a temperature which is lower than the temperature in the red. شو عم بصير أستاذ؟ في particles collide with each other, they have certain kinetic energy. وشوف هون، ركز هون يا صاحبي. في هون minimum energy needed for reaction أو simply activation energy. شوف, there is, concentrate on the blue one, on the blue graph. Most of the particles have energy بنسمي average kinetic energy, تمام? And small بنحكي part of the molecules under the curve have energy enough to overcome activation energy, or simply more than activation energy. شوف, number of molecules, small number of molecules having energy more than activation energy. طيب. As we increase the temperature, عشان there is a common mistake. As temperature increases, activation energy decreases. هذا غلط. It's not correct. Activation energy of a chemical reaction is a constant. But as you increase the temperature, more particles having energy, شوف الكيرف نزل, curve become less أو نحكي lower, and those particles move to produce or to have energy more than kinetic energy. Area under the curve. Area under the curve in the blue one is a small number of particles having energy than more than activation. Under the red one, شوف الكيرف shift to the right, وصار البيك lower. Lower peak and shifts to the right at higher temperature, which means we have more energy. شوف ال area under the peak. More collisions having energy to overcome activation energy. So if they ask us, Ustaz, if they give, let's say, the red one, or they ask us to draw the distribution at lower temperature. So you shift the distribution to the left and you increase the peak, or you make the peak higher. If they give us a certain distribution and they ask us to draw the effect of increasing the temperature, بتخلي distribution shifts to the right, you lower the peak of the graph. تمام? Simply, Ustaz, it's another way. We are saying the same things about effect of temperature. Yes, it's the same. بس هون to describe with Maxwell-Boltzmann distribution, normal distribution, a kind of normal distribution, the effect of temperature on rates of reaction. بالرسم أو theory. Sometimes you need both. Be careful, and you should be able to deal أو to explain using Maxwell-Boltzmann distribution أو simply using temperature or increasing the temperature. شو ضل عنا أستاذ بالفactors؟ في I think that most of you think about this factor once we said factors affecting rate of reaction. Catalysts, Ustaz, enzymes. Most of us, we know enzymes, Ustaz, we know catalysts, and we know that they are species or chemical compounds that increase the rate of chemical reaction without being consumed or changed in the overall chemical reaction. صح. Catalysts. عشان احنا AP, because we are AP students, we will talk more ونحكي أكتر عن catalysts. Catalyst في definition is a substance that increases the rate of chemical reaction without being used up, without chemically changed by the overall reaction. عشان there is a common idea إنه catalyst speeds up the reaction without being used up, without interfere the chemical reaction. لا احنا AP students. Now we know, or we should know, that catalyst enters the chemical reaction, affect the mechanism of the reaction, و make it faster. But overall it is regenerated أو reformed إذا بدك أسهل. catalyst enters the reaction, interfere with chemical reaction, تمام, and then it is regenerated when the reaction is completed. Overall, Ustaz, let's say for this reaction, one of the most common reactions, nitrogen plus hydrogen to produce ammonia. Haber process. Nitrogen gas plus 3 plus 3 moles of hydrogen to produce ammonia. This reaction, one of the most common reactions all over the world, Haber process, production of ammonia. The catalyst, the most common catalyst of this reaction is iron. تمام؟ وشو قصدك أستاذ؟ It's not being used up. Let's say we started this reaction and we add 10 grams of iron at the beginning of the reaction. تمام؟ The reaction proceeds faster. At the end of the reaction, when the reaction is completed, you will have 10 grams of iron at the end of the reaction. They're not being used up. طيب كيف أستاذ كيف? How does catalyst speed up the chemical reaction? First of all, you should not say anything about the kinetic energy. Kinetic energy, the only factor is temperature. تمام؟ اوعى. But how does catalyst speed up the chemical reaction? As I told you before, we have something like this, Ustaz, activation energy and reactant particles A and B, let's say, they are colliding to overcome activation energy. صح صح. Catalyst, let's say this is the catalyst. كويس. A or B, and this is the catalyst. When catalyst is added to the chemical reaction, it, let's say, interact with A. Now we collide, or A collide with B in the presence of catalyst. By the way, this is intermediate. إيش أستاذ؟ Intermediate. We will talk about it. But when catalyst bonded to one of the reactants and then they collide with each other in the presence of catalyst, catalyst is regenerated وproduct is formed. شو سوى catalyst؟ الcatalyst derive make the chemical reaction happens with different route, different mechanism, and this mechanism needs lower activation energy. يعني with the presence of catalyst, if we add a catalyst, this energy or activation energy, the reaction goes different way with, let's say, this amount of activation energy. يعني it's easier to overcome activation energy in the presence of catalyst, which leads to a faster chemical reaction. كمان مرة أستاذ, catalyst, we add catalyst. كويس? Catalyst start to interfere or change the mechanism of the chemical reaction or drive the chemical reaction to a different route. This route needs lower activation energy. خلنا أفرجيك شغلة كويسة وفي هيك questions. Let me show you a good thing that to combine concepts with each other, Ustaz. We know that the energy profile we discussed before, let's say we have this exothermic reaction. Energy profile. This reactants and products. And this is the activation energy of the reaction. Listen, we did not add a catalyst. It is an uncatalyzed chemical reaction. يعني reaction occurs with no or without a catalyst. If we add a catalyst, this energy profile becomes this way. هنحط لون. شوف. You start from the same points and end at the same point. يعني احنا we're talking about the same reactants and the same products. احنا we just add a catalyst. عشان في طلاب, if they ask us to draw it, they start to do something like this. This is incorrect because you start with different energy. So different energy of reactants. So you should be careful, Ustaz. We start from reactants and we end with products. So, yeah, Ustaz. So, if they ask us to describe the presence of catalyst or the effect of catalyst, we have to do something like this. شايف? We start and we end up at the same points. But the activation energy of the catalyzed reaction, the purple one, catalyzed reaction, is lower. At the end of the reaction proceeds at faster time and you have the catalyst the same, not being used up, not being chemically changed. That's it. So حتى if endothermic reactions, even in endothermic reactions, catalyst lowers. We could say that they are lowering the activation energy. But since we're AP students, يعني هذا grade 9, grade 10, we say that catalysts lower the activation energy. But actually, catalysts drive the chemical reaction in an alternative route with lower activation energy. تمام? And they're not being consumed or chemically changed by the overall reaction. طيب, enzymes, as we said before, biological catalysts. and the old theory, now it is old theory, the lock and key theory. You know, substrates and enzymes, they have shapes that match with each other. Reaction occurs in the presence of catalyst, so the product has different shape, and it is removed from the catalyst, and the catalyst remains the same. This is an old theory now. It's not a good one to explain the effect or the act of enzymes. طيب يا أستاذ، طيب يا أستاذ. What do we have next? لا مش خلص روح. شكرا. Two types of catalysts, homogeneous and heterogeneous. سهلة أستاذ. Homogeneous catalyst يعني if the reactants and the catalysts are in the same phase. For example, we have a reaction occurs in solution, aqueous substances, and a catalyst is also dissolved in the solution, so they are in the same phase. They're all aqueous. Reactants are aqueous, catalyst is aqueous, so this is a homogeneous catalyst. It's easy, Ustaz, to decide. If reactants and catalyst are in the same phase, let's say we have solid reactant, and a solid catalyst. Homogeneous catalyst. Heterogeneous catalyst, Ustaz, says أنا بعرف قولي بنتي قولي إنه reactants have different phase than the phase of catalyst. ممتاز. Reactants and catalysts are in different phases. For example, اللي حطينا قبل شوي, the one that we talked about before, nitrogen with hydrogen, they're both gases, and the catalyst is iron, solid. This is a heterogeneous catalyst. In AP, you need to know how do heterogeneous catalysts, or simply when we have a gas reactants with a solid catalyst, one of the theories, active site theory, to explain how catalyst speeds up chemical reactions. شو بصير أستاذ؟ First of all, خلنا أفرجيك. Let's say this is the catalyst, the surface of the catalyst, a transition metal, iron. In the other example, والله غير أكتب كمان مرة. Nitrogen with hydrogen to produce ammonia. 2, 3. Gas. And the catalyst is iron. Solid. Heterogeneous catalyst. شو عم بصير أستاذ؟ أو what the theory says. What you need to know. Catalyst, transition metal, they assume that on the surface of catalyst there are parts of the catalyst أو sites بنسميهم active sites. تمام? On the surface of catalyst there are active sites. Gases pass over the surface of the catalyst. Gas molecules adsorbed on the active sites. Absorbed أستاذ ولا adsorbed؟ لا adsorbed on the active sites. And they just stick, or they stuck on the surface of the catalyst. Absorption takes the molecules in. No. It's not absorption. It's adsorption. يعني the first step إنه gas particles pass on the top of the catalyst, and gas reactants adsorbed on the active sites. تمام? When they are adsorbed on the active site, they react with each other in the presence of the catalyst, which provides an alternative route with lower activation energy. So the reaction happens on the surface of the catalyst, on the active sites. Products are formed and then they are desorbed away from the active site. شو أستاذ? You need to explain the active site theory. First of all, gas reactants adsorbed on the active sites of the catalyst. They react with each other with lower activation energy in the presence of catalyst. And the product is desorbed away from the active site. Adsorption, reaction with lower activation energy, desorption. حطهم عندك points, والله نصيحة اكتبهم. Adsorption, reaction in the presence of catalyst, lower activation energy, desorption. Adsorption للreactants, desorption للproducts. And we have another example with the drawings. جبت رسمات الصراحة مرتبين. We have this reaction of ethene with hydrogen to produce ethane, C2H6. يسموه hydrogenation reactions of alkenes. It doesn't matter. It says the catalyst is nickel catalyst. Solid nickel transition metal. تذكرت معي؟ فاهم شو قصدي؟ شو بدي احكي هلا؟ استاذ. We took this زمان in chapter 2. One of the properties of transition metals, one of the common properties of transition metals. شوف. Ammonia production, iron catalyst. Iron is a transition metal. C2H4 plus hydrogen, nickel catalyst. Nickel is a transition metal. الحمد لله انك تذكرتها والله انك شاطر يا صاحبي. طيب I summarized this. Adsorption of reactants on the surface of the catalyst, active sites. Reactants in the presence of catalyst react with lower activation energy. اكتبهم please أو سيفهم عندك. Write them down on the notebook, on your notebook please. If they ask us to explain, you need these three نحكي keywords. Adsorption of reactants on the active sites, reaction in the presence of catalyst with lower activation energy, products desorbed away from the active site of the catalyst. Desorption of product away from the catalyst. This is the drawing to represent the reaction in the previous slide. C2H4 plus hydrogen to produce C2H6, or ethene plus hydrogen in the presence of nickel catalyst to produce ethane. Says, do we need to know the names? No, you don't need to know the names. And this is only to explain the idea of heterogeneous catalysis. When we have a solid catalyst with a gas reactants. شوفي بنتي. First of all, we have the catalyst, solid nickel catalyst. Do we need to memorize? It says it's nickel. No, this is an example. Nickel catalyst with active sites on the surface of nickel. Ethene molecule, hydrogen molecule adsorbed on the surface of nickel, on the active sites of nickel. Ethene molecules adsorbed. شوف, hydrogen molecule break down into hydrogen atoms, each one on an active site. تمام? This is adsorption. طيب. Now, Ustaz, ethene molecule reacted with the hydrogen on this side, so becomes C2H5, and then hydrogen C2H6, and then, Ustaz, ethane molecule or C2H6, or simply the product, is desorbed away from the active site. تمام أستاذ. First of all, active sites, solid catalyst. Adsorption on the active sites. Reaction in the presence of the active sites with lower activation energy. So the reaction is faster, product is formed, and desorbed away from the active site. يعني أستاذ, we need to summarize this simply. Adsorption of reactants on active sites, reaction in the presence of the catalyst with lower activation energy, and finally, product desorbed away from the active site. Now I'm going to introduce rates of reaction, بس إيش calculations. Now this is the largest part of the chapter, أستاذ. إنه how to calculate rates, what's the difference between a rate of reaction in rate law, integrated rate law, instantaneous rate. خلينا نشوف سوا. Reaction rates can be measured, as we said before, by monitoring one of the changes, one of the variables, temperature, concentration, pressure, mass, electrical conductivity, as we said before. But commonly, Ustaz, we use change in concentration. And if you start with certain amount of reactants, خلينا مروقين على الهادي. يعني let's think about it هيك شوي. If we start a chemical reaction with certain amounts of reactants, time zero. Listen, we did not start yet. We mix them with each other, so the reaction starts to occur. Concentration of reactants decrease with time. So we can make, Ustaz, a graph, concentration versus time. ركز بالله عليك بنتي ركزي شوي. Concentration of reactants decreases with time. If we can measure the change in concentration of the reactant with time, so simply we can find the rate of this reaction. صعبة؟ سهلة. If you're able to measure the change in concentration of a reactant with time. C4H9Cl plus H2O, C4H9OH plus HCl. The concentration of butyl chloride C4H9Cl is measured at various times. شو بدنا نسوي أو what we expect to see in the exam. Measuring the concentration of the reactant C4H9Cl at time intervals. At the beginning, at time zero, we have concentration 0.1, 50 seconds 0.09, 100 seconds 0.08, 150 0.07, 0.06, 0.05, 0.04. So as you see, concentration of reactants or this reactant decreases with time. They are measuring the average rate. شو average rate أستاذ؟ Average rate, the simplest way to measure the rate. Average rate بدنا القلم. Average rate. هو بحكي لك. Let's say time from the beginning to time 100. From the beginning to time 100. You take the change in concentration over the change in time. That's it. Change in concentration over change in time. The easiest way. بس شوف كل مرة أستاذ average rate decreases with time. ركز. To calculate it, it's so easy. Let's say we're going to calculate it for the first 50 seconds. Okay? So the change in concentration 0.0905 minus 0.1 over 50 minus 0. This is rate. Change in concentration over change in time. So easy. But I need from you to notice that rate of reaction decreases with time. ليش? Since concentration of reactants decreases with time, so number of collisions decreases with time. Or they collide less frequently, so the rate decreases over time. خليك معي for the next video إن شاء الله. We're going to explain لسه في إشي اسمه instantaneous rate و initial rate. See you then يا صديقي. سلام عليكم.